One of the coolest things you can see in space is a supernova. But what exactly is a supernova? Welcome back to Hidden in the Stars. This episode we're breaking down supernova classifications. A supernova is a powerful, very bright stellar explosion. This is the fate of a large star. There are three main types of supernova: Type 1, Type 2, and Type 3. Type 1 is broken down into three subcategories: Type 1a, Type 1b, and Type 1c. Type 2 is broken down into two subcategories: Type 2-L and Type 2-P. Type 3 was discovered recently in March of 2018 and only has one category as of now. Supernova are characterized by their observed spectral lines. Spectral lines are lines in a light spectrum that are unique. They're sort of like fingerprints that appear when atoms or molecules either absorb or emit photons. Type 1 supernova are characterized by a lack of hydrogen in their spectra. Type 1a arise in binary systems and white dwarfs. The spectra shows little to no hydrogen and an excess of carbon, silicon, calcium, and iron. Type 1b and 1c supernova are referred to as stripped core collapse supernova. Type 1b supernova are results of stars at least 25 times the mass of the Sun going supernova. They have a lack of hydrogen and silicon in their spectra. Type 1c supernova form from the collapse of massive stars that have lost their outer layers and lack hydrogen and helium as well as silicon. They lose most of their initial envelope. An envelope just means the outer layers of a massive star. On to Type 2. Type 2 supernovae show hydrogen in their spectra. They originate from massive stars that are at least 8 times the mass of our Sun. Astronomy.com says, the progenitor stars of Type 2 supernova are massive enough to fuse elements up to iron, but once iron is reached, a black hole or neutron star can be left behind. A progenitor star is an original or parent star that evolves and becomes a supernova, black hole, or nebula, a star along those lines. Type 2p supernova are marked by a steady release of energy followed by a normal decline as part of their lifetime, while Type 2L supernova differ and linearly decline after exploding. Finally, Type 3 supernova are called electron capture because in the dense cores of these stars, electrons are captured by magnesium and neon atoms. This rapid capture of electrons reduces the number of free electrons, which contributes to the outward pressure. This upsets the hydrostatic equilibrium, resisting the star's gravitational collapse, leading to an implosion, therefore a supernova. Many stars we know, such as the favored Betelgeuse and Rigel, have supernova futures. Even the famed Bellatrix has such. So take a minute and think. What kind of supernova are you? Do you emit hydrogen spectra? Do you capture free electrons? If you were a star, what would your fate be? Thanks for joining us on our journey through the cosmos. Catch you next time here at Hidden in the Stars.